Hey there, young scientists, it's your old pal Bill Nye here, and guess what? Today, we're diving headfirst into the totally rad world of chemical reactions. Get ready to unleash your inner scientist. We're talking bubbling potions, color-changing concoctions, and maybe even a little bit of fizz. Safety first, of course. We've got 3 awesome experiments lined up for you today. First, we're going to be like detectives searching for clues, looking for evidence of a chemical reaction. Color changes, gas production, temperature differences, we'll see if we can spot them all. Next up, we're tackling the law of conservation of mass. Don't worry, it's not as complicated as it sounds. We're going to prove that in a chemical reaction, matter is never created or destroyed, just transformed. And finally, we're going to explore the wild world of acids, bases, and the pH scale. We'll even learn how to test liquids using a natural pH indicator. How cool is that? So put on your safety goggles, grab your lab coats, and let's get this science party started. Remember, science is everywhere, and it's for everyone. Let's make some magic happen. Alright, science sleuths, let's talk about chemical reactions. Now, a chemical reaction is like a recipe for change. You mix certain ingredients together, and bam! You get something totally new. But how do we know if a chemical reaction has actually occurred? That's where the evidence comes in. Think of it like this. Imagine you're baking a cake. You mix together flour, sugar, eggs, all that good stuff. But until you bake it, it's not really a cake, is it? It's just a goopy mess. Same thing with chemical reactions. We need to look for signs, for evidence, that a change has happened on a molecular level. So, what kind of evidence are we looking for? Well, one of the most obvious signs is a color change. Like when you mix baking soda and vinegar together. Whoa, instant volcano! That's a chemical reaction in action, folks. The mixture changes from white to foamy white, releasing carbon dioxide gas in the process. Pretty cool, huh? Another telltale sign is the production of gas. Remember that baking soda and vinegar volcano? All those bubbles? That's gas being released. And sometimes you can even smell the gas being produced. Like when you strike a match, that sulfurous smell is a dead giveaway that a chemical reaction is happening. And last but not least, we've got temperature changes. Sometimes chemical reactions can release heat, making the surroundings warmer. Think about what happens when you mix certain chemicals together to make a hand warmer instant heat. On the other hand, some reactions actually absorb heat, making the surroundings colder. That's how those instant ice packs work. Now it's important to remember that not all chemical reactions produce all 3 of these signs. Sometimes you might only see 1 or 2, but if you see any of these changes happening, it's a good bet that a chemical reaction is taking place. So keep your eyes peeled, your noses twitching, and your hands ready to feel for temperature changes. You never know when you might stumble upon a chemical reaction in the wild. And remember, always be safe when experimenting with chemicals. Wear your safety goggles and gloves, and always have an adult present. Safety first, science second. Alright, science superstars, get ready to have your minds blown wide open because we're about to tackle the amazing law of conservation of mass. Now this law is super important because it tells us that in a chemical reaction, matter is never created or destroyed, just transformed. It's like a magic trick, but with science. Think of it like this. Imagine you have a Lego castle. Now, you decide to take that castle apart and build a spaceship instead. You've changed the form of the Legos, but you haven't lost any Legos in the process, right? You still have the same number of bricks. That's exactly what happens in a chemical reaction. The atoms, which are like our Lego bricks, rearrange themselves to form new substances, but the total number of atoms stays the same. No atoms are created and no atoms are destroyed. Pretty neat, huh? Now you might be thinking, but Bill, what about when I burn a piece of paper? It seems like the paper disappears. Well, hold your horses there, buckaroo. The paper may seem like it's gone, but it's actually just changed form. When you burn paper, it reacts with oxygen in the air, producing ash, carbon dioxide gas, and water vapor. The atoms in the paper haven't disappeared, they've just rearranged themselves into new substances. And guess what? If we could somehow capture all those products of combustion, the ash, the carbon dioxide, and the water vapor, and measure their mass, we'd find that it's exactly equal to the mass of the original paper and the oxygen it reacted with. Mind-blowing, right? So the next time you see a chemical reaction happening, remember the law of conservation of mass. Matter is never created or destroyed, just transformed. It's like a cosmic game of musical chairs where the atoms are constantly switching places, but the total number of players always stays the same. Science is full of surprises, isn't it? Chapter 3. Acids, bases, and the pH scale. Test liquids using a natural pH indicator. Hold on to your lab coats, chemistry champions, because we're about to enter the wacky world of acids, bases, and the pH scale. Now the pH scale is like a measuring stick for how acidic or basic a solution is. It ranges from 0 to 14, with 0 being super acidic, 14 being super basic, and 7 being neutral, right in the middle. Think of it like this. Acids are like the Sour Patch Kids of the chemistry world. They taste sour, can be corrosive, and have a low pH. Lemons, vinegar, even battery acid, those are all acids. Bases, on the other hand, are like the mellow yellow of the chemistry world. They taste bitter, can be slippery, and have a high pH. Baking soda, soap, even drain cleaner, those are all bases. Now to measure pH, scientists use something called a pH indicator. A pH indicator is a special substance that changes color depending on the pH of the solution it's in. Pretty cool, huh? And guess what? You can even make your own pH indicator at home using red cabbage. That's right, red cabbage contains a natural pH indicator called anthocyanin. Anthocyanin changes color depending on the acidity or basicity of the solution it's in. In acidic solutions it turns red or pink. In neutral solutions it's purple. And in basic solutions it turns blue or green. So to make your own red cabbage pH indicator, simply chop up some red cabbage, boil it in water for a few minutes, and then strain out the cabbage. The leftover liquid is your pH indicator. You can test it out on different liquids around your house like lemon juice, vinegar, baking soda solution, and even water. Just add a few drops of your red cabbage indicator to each liquid and watch the colors change. The pH scale is a super important concept in chemistry, and it affects everything from the food we eat to the medicines we take. So the next time you're chowing down on a juicy orange or using soap to wash your hands, remember the pH scale and the amazing world of acids and bases. Science is everywhere and it's delicious. Well, that was a blast. We explored the wonders of chemical reactions, from color changes and gas production to the mind-boggling law of conservation of mass. Remember, science is more than just textbooks and beakers. It's a way of understanding the world around us. Keep experimenting, keep asking questions, and keep that curiosity burning bright. Who knows what amazing discoveries you'll make? Remember, the world of science is vast and full of wonders just waiting to be explored. So go out there, embrace your inner scientist, and never stop learning. And hey, if you ever need a science buddy, you know where to find me. Until next time, stay curious.